Right, so solve. And I don't have the picture, so I'll just label it. A is 20.5 degrees, which is not a very big angle. So here's my pen. 20.5 would be something like, so I want B to be like 3 times A. Right. So there's A, B, and C. And B is going to be somewhere out there. A is this side right there, which again, we're not quite sure what we've got yet, but A is 12, B is 31, and this angle is 20.5. So we have to solve for angle B, always the starting place, right? So in this scenario. So we say sine of B over B equals sine of A over A. Right, we substitute sine of B divided by 31 equals the sine of 20.5 divided by 12. So we say sine B equals 31 sine of 20.5 divided by 12. Sine of B equals. Has anybody got it? I can look it up over here. 0.9047. I would usually carry like 4 decimal places because the sign could be like really sensitive about that. Okay, now what does that make angle B? Sine inverse 64.8. Okay. Okay, so if we fill this in, we say that's 64.8. Then we could subtract 180 minus 20.5 minus 64.8, and we're going to get C equals somebody? 94.7, good. Okay, but here's the thing we got to check. Now we can find the C, right? We can find the C. In fact, let's just do that first. That was angle C was 94.7. So in order to find side C, we're going to go C over the sine of 94.7 equals, and it doesn't matter which one, since I've got this right here, I'm going to say 12 over the sine of 20.5. So C equals 12 sine of 94.7 divided by the sine of 20.5. C equals somebody? 34.15, okay, 34.2. Okay. Now, what would have happened? I mean, here's the thing you got to look at here. We know, this is chapter 4 stuff. We know that sine could actually equal a positive 0.9047 in 2 different quadrants. Right? If I draw a unit circle, where is sine positive? Sine is a y-coordinate. First and second, right? So if this angle of 64.8 is about right there, right, 64.8, then actually we ought to be able to go straight across into quadrant 2 and find another angle where sine has exactly the same value, okay? And you always have to do that. So we're going to do this math right here, okay? How do I find this angle? This was 64.8 degrees up from 0. This is 64.8 degrees up from 180. What's that? Okay, 180 minus 64.8, which is 115.2? 115.2. Okay. Now, imagine that our C, what's the question? Because sine has the same value in these two quadrants, right? If this is 64.8 up here, this is 64.8 up from 180. So 180 minus 64.8, 115.2. Imagine if we had here, we started out with the A is 20.5, and now we've got our C is 115.2. What if we said, we didn't have 64.8 as the answer, it's actually 115.2. If you add these up, as long as they're less than 180, that's another triangle. That's when you get the situation that you have two triangles. Because you do this thing here, find the second angle, which is in the second quadrant, and then add it up with the A that you already have. If that's less than 180, there's your second triangle. And this is the one that we explained would be the obtuse angle, right? Closer to the side B. It's 115.2, that's obtuse. I mean, we should have done the same thing. Let me stop this recording.